welcome to Teaching with Panchal, class 12th, chapter number 4, chemical kinetics. So now first I introduce about the chapter introduction, the rate of reaction. The rate of reaction is the reactant is changed into product at the change in concentration with respect to time. Now today's lecture we can study the integrated rate equation for zero order. So for zero order reaction, it means that the rate of reaction is proportional to the zero power of the concentration of the reactant. So we can start now. For the integration of rate equation for zero order, now the reactant is changed into product. So reactant is equal to minus dr by dt is equal to k concentration of reactant into power 0. So power of 0 is the unity, means the value of r0 is equal to 1. So here we change the sign dr, negative to positive. Dr is equal to minus k dt. Now integrating both sides, so we get r is equal to minus kt plus I, where the I is the constant of integration. Now at the time t, the constant at the time t is equal to 0, the concentration of reactant R is equal to R0, where R0 is initial concentration. So we substitute R is equal to R0 in equation first, where t is equal to 0. So R0 is equal to minus k into time is 0 plus I. So we get R0 initial reactant constant is equal to R. Now we can substitute I is equal to R0 in first equation. So first equation R is equal to minus kt plus I. So reactant is equal to minus kt plus R0. So about this, R is equal to minus kt plus R0, where the value of k is equal to R0 minus R upon T. So we recap the for first order reaction. The rate of reaction is proportional to 0 power of the concentration of reactant. The reactant is changed into product. So when we can choose the rate of reaction of reactant, then minus dr by dt upon is equal to k r raised to power 0 for zero order reaction. When we take the first order, then we can add first. So R0 is the power is the unity, so we can put the value of R0 is 1. dr is equal to minus k dt. We change the sign dt placed to kr, so dt k into 1, R0 is 1, so dt k dt. We change the sign minus dr to here, so dr is equal to minus k dt. Now integrating both sides, so r is equal to minus kt plus I. We can take the first equation where I is the constant of integration. At the time of t is equal to 0, the concentration of reactant R is equal to R naught, where R naught is the initial concentration. So we can substitute the R is equal to R naught and T is equal to 0 in first reaction. So we can get R naught is equal to minus K into 0 plus I. R naught is equal to I. Now we take the R naught, R is equal to minus KT plus I. The I is equal to R naught. R is equal to minus kt plus R naught. So value of k is equal to R naught minus R upon T. Now according to textbook, NCERT textbook, the whole theory we can complete it. So the graph of the zero order reaction is the concentration upon time, k is the minus slope. According to we comparing, now we can comparing the y is equal to mx plus c, then the value of slope is equal to minus k. So the intercept shape to the r naught is slope is minus negative sign. So the slope is in the negative direction, in the negative value of k. For zero order reaction relative the uncommon, but they are occur in special conditions. Some enzymes catalyst reaction. The reaction which occur at the metal surface are the few example of zero order reaction. The decomposition of gaseous ammonia on hot platinum surface is zero order reaction at high pressure. So the reaction 2NH3 at gaseous change 1130 Kelvin platinum to N2 gas plus 3H2 gas. The rate of the reaction is equal to K NH3 zero order is equal to K. So in this reaction, platinum metal acts as a catalyst at high pressure. The metal surface gets saturated with gas molecules. So further, the change in the reaction condition is the unavailable to alter the amount of ammonia on the surface of catalyst, making the rate of reaction independent of its concentration. The thermal decomposition of Hi on gold surface is another example of zero order reaction. So today we are studying the zero order reaction. So thank you. Like, subscribe and comment on this video. Thank you.